If you have questions, you can ask. I may or may not answer your questions. My goal for doing this is not to give away all the secrets of the experiment. It's just to kind of show you what's going to happen so you have an idea what to watch for, so on and so forth.
Will this be online?
Mr. Weens is recording it right now, so
Mr.
it may or may not be.
Like
What do we have here?
Copper.
Copper, lovely. So we'll kind of, take like a chunk of this guy and chop it off, and it looks like some copper. Mosey on over here. Oh, look, it's a scale.
I know.
Oh, how wonderful. Kind of wind it up, that way it's easier to measure. Okay, 0.44 grams. That's wonderful. By the way, if I were you, I would be like writing down notes or tips, because remember, I'm not giving you a procedure. So, this is your procedure. So this guy was what, like 0.44 grams or whatever? I got myself a nice little small beaker because I don't have very much wire, right? I'm going to drop this in, and I'm going to do my first reaction. You guys all have the first reaction written there?
Yes.
Yes.
Anybody know what HNO3 is? That's what we're doing in the first reaction.
Something nitric.
Very nice. It is nitric acid. Very nice. And I'm going to have you scooch. Because the nitric acid we are using today, ladies and gentlemen, is 16 molar nitric acid. This will literally take the skin off your hand. Okay? So, very, 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 very dangerous.
Can we get gloves?
Alright? No, you're not.
Second thought.
So,
Be careful.
Yeah,
so take a step away then.
No, him.
Oh, no. So, her comment. He's going to spill it on her. Not a chance. Because Mr. Harshfield is going to handle this for you. Alright? So, when you have your copper and you are ready to do the first reaction and you are wearing the proper safety gear, you will come forward and you will find me and I will be right here at the fume hood. Why am I at the fume hood? Take a look at your first balanced reaction. What are the products of the first reaction? Gas. Okay? There is a gas produced. It is NO2, nitrogen dioxide. It is brown in color. If you've been to Los Angeles, you've seen it. It's in the air. This is super concentrated. You do not want to breathe it. It is considered toxic. Alright? So we are going to do the reaction in Mr. Fume Hood. Right? You've all been wondering, what is this device? This is the fume hood. Is my switch on, Jazzy? Yeah. So, we don't need a whole heck of a lot. I call it 1 squirtful, 1 pipette. It's approximately 2 milliliters. Alright? So it doesn't take very much. This stuff is so concentrated, a little bit goes a long way. You can see it's initially turning a little bit of color. And now it's starting to dissolve the metal. You see some bubbling. Oh, look at that brown stuff. There it is. Alright?
Wait, yeah, is this what we are supposed to be
So the brown stuff is going to start coming out here. Now it's really bubbling. Now the brown stuff's coming out. Yeah, we're going to put that in the fume hood. And we're going to let it just kind of sit there for a couple of minutes.
Everybody falls.
What are the products supposed to be? Obviously, nitrogen dioxide gas and
Yeah.
2 NO2. That's the nitrogen gas, nitrogen dioxide gas. What's the other one?
2O.
Water. What else? Copper.
Nitrous.
Look at the formula. What is it? Copper with what?
Nitrate.
Copper nitrate, right? And in case you're wondering what copper nitrate looks like, copper nitrate, this is one that's already, notice the metal's all gone. This is one I put in there last period. The whole reaction takes maybe 5 minutes or longer.
Do this for
Alright? So we're just going to let that one keep doing its thing. But we're going to come up with some copper nitrate solution. The copper is now, what's the magic word? Starts with letter A. Aqueous, right? So if it's aqueous, it's like it disappeared, it's gone. Copper often turns blue when it becomes aqueous. What we're going to do is we want to water this down because it's really, really concentrated. So we're going to add 100 milliliters of water.
More or less.
I'm just cheating here. Right? So obviously, my beaker's a little small. I probably would need a slightly larger beaker at this point in order to actually get 100 milliliters of water. Is adding water to this, that's not a reaction we wrote down. Is this a chemical reaction?
No.
No, right? I'm just adding some water so I basically have more volume, more space. It also reduces the concentration in case there was some leftover acid and this got spilled or something, right? It makes it safer to work with, all right? What's our second reaction?
Copper nitrate.
Very good, sir. Plus?
I don't know how to say that. Sodium hydroxide.
Very nice, ladies and gentlemen. I knew you could figure it out. Sodium hydroxide. Perfect. And the sodium hydroxide, remember my nitric acid was 16 molar? The sodium hydroxide is 3 molar. Okay? So this is still dangerous in terms of you don't want this in your eye or something to that effect. But if you got this on your skin, your skin would feel all slippery and you would just go wash your hands and you'd be fine. Alright? This is half as concentrated as the stuff we used to make your soap. Your soap was 6. Okay? So, we need 30 milliliters of sodium hydroxide. So, I'll give myself a little graduated cylinder here. We'll measure 30. Okay? Close enough. Should I pour this straight in here? Probably not such a good idea because my beaker's looking a little full. So I'm going to go ahead and switch this over. Oh, there's still a little bit of blue in here. This just don't have the drain, right?
No.
Oh wait, this is my copper that I want to get back in the end. So I probably should be extra careful to like not lose any of my copper, right?
Well, you do it all at bigger.
To the best of my ability, right? I'm doing this a little fast, okay? So, here's my copper nitrate. Here's my sodium hydroxide. I'll back up so you guys can all see this. This one goes really, really fast and it looks kind of cool. You ready? Do it. This is what I call a chunky reaction.
Holy crap.
Starts with letter P. It's a precipitate. Very good. So this is a solid, it kind of looks like gel. It's like a precipitate. Okay, this is reaction number 2. Hopefully you guys are making notes about these. Alright? That's why I'm doing this, so you can make notes. And that when you come back next week and try to do this reaction, you can remember what the heck I said. So what is this product then, if you look on reaction number 2? Copper what? They're all copper, right? What's OH again?
Hydroxide.
Very good, right? Same word, right? Different chemicals. So now I have copper hydroxide. Why do I still have liquid?
Because the night.
What are the other products?
Sodium
Sodium nitrate, okay. And the sodium nitrate must be aqueous. And what did I add before? Water. So it's normal. This is it's okay, right? There's still some liquid in there. No big deal, right? Okay. Questions about the first 2 reactions thus far?
What did you say it was called?
Copper hydroxide. The
Oh,
OH means hydroxide, right?
guys, you're
And if I look at this, hey, this was my one I just had going a minute ago. All right, is any copper left in there? No, it's all gone. So again, remember, I weighed my copper at the very beginning, but am I weighing anything else along the way? No. So I need to be making observation. What type of data is observation?
qualitative.
Very nice, qualitative. So what would be a really good qualitative observation to let me know I'm done with reaction 1, ready to go to reaction 2?
No copper.
No copper. So, and this is totally aqueous. Very good. And this is just a simple solution. Same deal. I could pour this into a larger beaker. Same deal. I could rinse this a little bit with a little bit of water. I know it looks green, but once you add a little bit of water, it actually
because the concentration changed?
it actually is blue. Right? So when it's really concentrated, it looks more of an aqua or greenish. All right? Remember, adding water, not a chemical reaction. Okay? Reaction number 3. Everybody ready? This chemical? Could I touch it? You could, but remember, I mean, you don't want chemicals on your fingers anytime, right?
It looks like jello.
It looks kind of like Jello. Let's say,
What would it feel like? I want to know now. I'm wondering now.
remember, this is a solid precipitate. Let's say I had something like a stirring rod and I was stirring my chemical and some of it like stuck to my stirring rod and I pulled it out and like rinsed my stirring rod off.
You just lost copper.
Oh, nuts, right? So there are lots of ways for you to blow this experiment, all right? Because remember, the purpose of the experiment is to get as much copper back as you can, all right? So lots of things to talk about in your conclusion because it's so many reactions. For reaction number 3, we are simply going to oxidize our copper hydroxide. One of the easiest ways to oxidize our copper hydroxide is to simply heat it. Okay? So we're going to heat our solution. You're going to have to say in your procedure how to set the stuff up, what we're doing. All right? At this point in the year, folks, I'm going to assume that you all understand how to set up a boiling apparatus. Right? So in which case, you don't need to do that thing that you had to do way back at the start of the year where you say how to do each step to get it set up. You don't need to describe how to light the Bunsen burner, right? Just throwing that out there, all right? Let's focus on the actual chemical reactions for the most part. It is good to tell me what equipment to use, right? If you just said, you know, heat the chemical to oxidize.
What's
Well,
that?
could I use a hot plate? Do you want this? Like what temperature? So try to be a little bit specific.
Is that cylinder beaker or what should we call it?
This graduated
There you go.
cylinder.
That's
You
what I
got
meant.
it. Yep. And remember, there are many different kinds. Ooh. How do I differentiate in my procedure?
Pick one little lead.
Nope.
How many milliliters it contains?
A+, Joe. The number of milliliters. This is a 100 milliliter graduated cylinder. This is a 10 milliliter graduated cylinder.
Recording it.
This is a 100 milliliter beaker. This is a 250 milliliter beaker. So you can see that it's starting to change.
You should be.
Oh, relax.
Boom.
So it's slowly starting to change color here a little bit. All right. If I wanted to, I could stir it, but again, you got to be careful. All right. Do I want this to like boil and splash all over the place?
Yes.
Your grade's over there somewhere. All right. So it's true. So the whole idea here is just to gently heat it. So as it does this, folks, it's gonna all turn what color?
Black.
So again, we're using our qualitative data to decide when the experiment is done and we're ready to go to the
Will it
next
still
step.
be gel?
Good question. When it's all finished, it's going to look all cloudy. This is a good stopping point between one day and the next day. Why is it a good stopping point?
Because it's not going to change.
No, that's not true. Good guess though. It's a good stopping point because one, these three reactions are going to take you guys a little while to do. You got to set up your equipment, so on and so forth. So naturally, right, you don't want to be pressed for time. Two, if you let it sit, all the dark stuff will do what? Settle to the bottom. Okay? Because it is a solid and it is more dense.
So you can get rid
What's
of
this black stuff called? Copper and oxygen makes copper
Copper oxide.
oxide, right? And what's the formula for copper oxide? Check your balance
CuO2.
equation. CuO, right? So I'm done with my first three reactions, all the way finished, and then I, label this guy, set it off on a cart, and I come back 2 days later, for my next period of chemistry, and it's all settled down to the bottom, right? Is it okay that there's all this liquid in here? Sure. It's mostly water. I mean, it tells you what the other products are. They're listed there in your balanced reactions. But all we really care about is the copper. Right? Okay. Any questions about this guy? So, how long did this take?
Not very long.
Didn't take very long, right? And again, it's all about my qualitative observations, and that's when I know I'm ready to move on. Right? So we can see, Maddie's doing a nice job pointing out here with Alicia. We can see, it's not quite there yet, right? But it's getting close. Okay? If we discover it's doing something crazy, too much energy, well, goodness, just turn the heat down. We don't want this thing. All right, yeah. There you go. Yeah, you probably don't need to blowtorch the side of my beaker. All right. Sorry. Look, I've seen people do lots of strange things. All right. We're ready to go to probably day 2, which would be reaction 4. Okay. So you come back from your little couple of days off of chemistry, and you find your beaker and your copper oxide is all settled down. You are going to do something with this liquid. You're going to say bye-bye to the liquid. It's called decanting. Anybody remember what decanting is? You don't need a filter, but the idea is,
I have a question. When we do the procedures, do we break it up into days?
however you want. However you want. It's your procedure, right? You're in charge. So decanting, ladies and gentlemen, is the idea that the chemicals will separate based on density, right? So if I gently, carefully pour this, does the solid copper oxide come out? No. And it doesn't. You can. There are various levels of carefulness, right? You can really go forward. You can slow it down. I'm going to go faster because I don't want to waste time. But we can pour this out, and then I'm starting to lose some of my copper, so I'm going to stop. All right. So you need to be careful, but you don't want all that extra liquid. Okay? You need to get rid of some of that liquid, so you need to do some decanting. Mine was that chemical. This little guy sat for like an hour, and it was mostly settled. Yours is going to sit for 2 days. It's going to be totally settled. That solution will be crystal clear. All right. So we're going to start with decanting. What is our fourth reaction after we decant? Starts with an H. H2, SO4. SO4 is sulfate. It starts with an H, so it's probably an acid, so it must be sulfuric acid. Okay. Okay. So we got sulfuric acid. This sounds like another Mr. Harshfield helping you out. How concentrated is this one?
18.
The last one was 16. Oh, good. This one's more concentrated. How fun. Okay. So we have 18 molarity concentrated sulfuric acid.
Can you demonstrate why we should?
Yeah, sure. Come over here. So I'm going to put, that was like one, this isn't even a pipette. This is like a squirter from a glass dropper. I put some of that in there. I'm going to swirl it around real good. Give the reaction, I don't know, maybe 30 seconds or 60 seconds. That was one squirt. I might need to put a second one in. This stuff is so concentrated, I don't need to put very much of the chemical in there. I do need to give it a little bit of time to do its thing. This is called sulfuric acid. Yes.
Okay, we're putting that stuff in that beaker? And the one came up?
Are you feeling for it to get when we put in the other one?
I thought I felt something.
What did you put it in?
What we do.
Let's try one more, and I think that'll probably do
You
it.
took out the water in this one that you drew here.
It's because that was like the next day. It's like you did
Yeah,
last period.
like this is how it should end.
That's how it should start by day 2.
Right.
That's precisely.
Okay, so one of the things that Taylor and maybe some of the folks, Eileen, have realized is that if you look at the various reactions we wrote down before, the end of the reaction is the beginning of the next reaction, right? The idea is to keep the copper moving along. We don't care about the other ones. You guys remember what we call the ones we don't care about? Right? Okay? So that's how we're treating them, right? This is the one Ellsbury did. I don't have any idea how much copper is used. May need a little bit more.
Holy cow.
What do you?
To demand it.
How much copper or how much sulfuric acid?
Yeah, obviously more copper would require more sulfuric acid.
What are you trying to?
What is it supposed to do?
I think he's going to do it.
Well, you guys have the balanced equation, so you tell me. What comes after you add this copper oxide and the sulfuric acid together?
CuSO4.
CuSO4. Copper sulfates. Anybody recall copper sulfates?
Yeah.
We used it, right? Very nice. It is bluish in color, okay? Well, it's starting to get there, okay? So that was 3 squirts, and my one I did first period only took 2. So, like I was saying, it all depends on how much copper you have to begin with. I started with 0.44 grams. That's what this was. I would say something around half a gram is probably a reasonable amount. There we go. See, there we go. I just had to give it a little bit of time, right? Give it a little bit of time, swirl it nice and good. Hey, we got our blue copper sulfates. All right? Questions about the fourth reaction? Yes, ma'am.
What about like all the extra black stuff around the
Good question. Notice my beaker, because I've been doing it pretty fast here today, I never rinsed any of the edges of this beaker. What do I have up here? Copper. And this is old copper that's from like a previous step that didn't get fully reacted. So that's probably something I should have dealt with along the way. That's a great qualitative observation. Okay? So you can see that even, I mean, that's only been like another 30 seconds. It's getting even more blue. Okay? So really, this is one of those reactions you just need to wait for it. Kind of like this one. Hey, it finally changed. It didn't boil over. How wonderful for us. Okay? And there it is. It looks all black and chunkified. But if I let this sit and cool for a day or two, it will all settle out. Okay? Trust in the chemical reactions that you have, the balanced chemical reactions. Those are what's going to take place. Last one. What's number 5?
Copper sulfate plus zinc.
And zinc.
Plus zinc. Does anyone recall the demonstration Mr. Weems did where he took the copper sulfate and he threw in some aluminum foil?
Yeah, the aluminum dissolved.
Right? The aluminum and the copper traded places. What type of reaction is it if only one chemical trades? Single replacement reaction. So in this particular step, we are not going to use aluminum. Instead, we are going to use zinc. And if we look at the periodic table, it's kind of high up there, Nate. I don't know if you can point to it or not. 29 and 30, copper and zinc, what do you notice about their locations compared to each other?
They're right next to each other.
Right? So not only does that imply that they have very similar reactivity, and they do, it also implies because they're next to each other, they weigh almost exactly the same. Right? Now, here's the trick, and Joey might have already realized this. Okay? Keep it to yourself if you did. Did I have a little piece of paper? Did it fall down on the floor?
He has that.
Yep, that's the one.
Joey's a gypsy.
In the city is green.
It must have flown off. Okay. So,
Ew, stop.
Did you guys see that? And it's like copper.
nope. Nope. So, here's my solid zinc. Okay? If I was to dump this whole thing of solid zinc in here, true or false, it would trade with copper, I would get copper. True. True or false, it would all become copper. Wow. So here's the key to that last step. You want to make sure that you only add enough zinc to get your copper back, but you don't add too much zinc so then you have a mix of zinc and copper in your final filter paper. Okay? Because, yeah, it started out as this nice, easily shaped wire. It's not going to come out as wire, ladies and gentlemen. Okay? It's going to come out as a very fine, powdery copper substance, right? And it's going to be stuck in your filter paper after it dries. You're not going to want to try and like scrape out. Like this is what I did first period. You can see, just pass it around. Just pass it around. Get your hand out. Goodness. So pass it around there. You can see it's just these little tiny fine grains of copper. I mean, you're not going to want to like try to scrape out some of them and stick to the filter paper. You're going to need to do something regarding the scale and the filter paper before you actually filter your chemical. All right. So if I dump in too much of this, it's not all going to react. And I'm going to get it in my filter paper, and I'm going to have some sort of a mixture of copper and zinc for my final mass. Remember, all we're weighing is the beginning and the end. And that's it. So, this was 0.44 or whatever originally, right?
Yeah.
So about how much of this do you think I should use? Because copper and zinc are like almost the same, right? So I get out my Mr. Scale here. How am I doing on time? What time is it?
You got
30.
12:32.
20 minutes. Perfect. Perfect. Okay. So how much was that to begin with, Nicole?
You have 0.37.
0.37. So I'm going to start with 0.37. on my little piece of paper, just, you know, to be on the safe side. Pour it in there, give it a nice little swirl around. This, if you recall from Mr. Ween's demonstration with the aluminum foil, is not a terribly fast reaction.
No.
It takes a little while. But one of the things you also should have remembered from Mr. Ween's demonstration was when he started at the beginning, the solution was nice and blue, but by the time he got to the end, why is the solution blue? What's in the solution to make it blue? Copper. What are we supposed to get out of the solution?
Copper.
So should the solution change color?
Yeah.
Okay. Remember, a lot of these experiments, and you can see you're starting to get some red chunks in there. Okay. So right now we've got some zinc, we've got some copper. They're kind of battling back and forth right now and trading places. This is a ring stand, right?
Ring stand.
I just call this a boiling apparatus. Right? You can call it whatever you like. And you should see, like, if I was to let this sit for a good period of time, I would really start to see the copper come out of solution. I would see the color start to change from blue to something else. Okay? I can see that I'm starting to get some copper there come out of solution. And if I let this sit for, like, let's say a half an hour, and it looked like all my zinc was gone, but it was still blue, what could maybe I do? Add a little bit more. Right? This is what I call a finesse experiment. This last piece, you're going to have to play with it, adjust it, tweak it, right? Some of you will do a nice job, others of you will mess it up, all right? And it will all be in your data. Last but not least, get yourself your filter paper, right? You guys all remember how to do this? From our, remember that water that was all nasty that we cleaned up and then you guys drank it?
I can't believe that.
Very good. So after you, so I folded it twice, over and over, right, Alex? And then I got something like this, and if I grab just one spot and I push it so 3 are on one side, 1 is on the other, this will plop down in a funnel. You can pour this in nice and carefully. I'm going to just fast forward here to the end, so just pretend I didn't do that. If I dump that in, then we can see as it filters down that I'm going to capture all of my solid pieces, right? I'm obviously going to need to let this thing dry out, right? Clearly, I'm going to have to let it dry. I could let it dry by just leaving it out on a table. I could let it dry by putting it in Mr. Harshfield's little gray oven over there and turn the oven on low, right? Whatever. If it was me personally, I would probably write my name on the filter paper before I got it all wet. All right, just a thought, just an idea. And you notice, I know it's hard to tell, but that color right there, that is, it's kind of a reddish. It's a really dark red, but that is your copper that we got back in the end. And it's going to be stuck to the filter paper. You're going to have to weigh it inside the filter paper. Multi-day experiment.
So should we
This is your end result.
Should we weigh the filter
Dylan.
paper?
weigh the filter paper before we pour the solution?
Ooh, that's a
Other questions?
Yes. Wait.
Yes.
Is it okay to like add water at any of the reactions?
Absolutely. So her question is, can we add water to any of the reactions? Yes, absolutely. And to be honest, if I got down to this little bit here and it was trying to settle, this stuff's still in solution, by the way. There it is. All right, I got my chunks in there, so I'll let them settle down. If I was concerned that, like, let's say I still had acid in here, I would fill it up with a bunch of water, let it settle down, dump the liquid off, keep the solid behind. I might rinse it a couple of times if I was concerned about the chemicals being too strong. And that's not a bad idea, because by the way, if you do this process and you don't remove any of the acid, if the acid's too strong, guess what the acid will do to your filter paper? It will eat it away.
See, can we show what the acid will do using
On
the filter
paper?
paper?
Yes.
Please?
Other questions?
Jordy wins.
We need to
Look,
know.
I just dissolved copper with acid. I mean, it doesn't get much cooler than that. That's pretty much ninja skills
Can we
right
just see
there.
it?
Or
Could you
do we
do
do
it?
What?
Could you just on the table like you spill something on it?
There's a large stain over on that table over there. No.
That's Ivy.
Go find it, Alex. Other table. Yep. Walk. Yep. See that big old stain right there?
Yeah.
Right there at the end?
On the black table.
Yeah.
You feel that? Feel the surface has been like burned off.
I'm feeling it.
That was from IB chemistry last year. One of my students had a small beaker of this, and they knocked it over, and it spilled on the table and on the floor, and I got it stuff. I was cleaning it, and it sat there for maybe 4 or 5 minutes. It was
that's pretty
starting
cool.
to eat away my table.
That's really
Cool. Sucks. Should've just let it go. Wait, how did you clean it up? Wait, how did you clean it up?
No more questions?
How did you clean it up?
All right. Right now, you are planning your inquiry. Go find a partner.
How many partners can I have?